Nmap. During the process of footprinting, penetration testers need to gather information on their target. They can gather this information through either active or passive reconnaissance. A tool commonly used during footprinting and in active reconnaissance is Nmap, an open source scanning tool that uses IP packets to find hosts and gather information on said hosts. According to the official site for Nmap, Nmap uses raw IP packets in novel ways to determine what hosts are available on the network, what services, application name, and version those hosts are offering, what operating systems and OS versions they are running, what types of packet filters and or firewalls that are in use, and dozens of other characteristics. This can be extremely helpful for penetration testers during the footprinting process. Nmap is also free and can be used on any major operating system, which has allowed it to become one of the most popular networking scanning tools in the world. Users can also perform a multitude of scans to gather the information they need on their target. Some of the benefits or pluses of Nmap are it's a scanning tool, it's open source, it's free, user friendly, popular, it's powerful, with much to offer. It also works on any major OS, as already stated, and it's well documented as there's many tutorials, journals, and there's even Nmap has its own book. Application. Nmap can be used for different purposes, including network mapping, port scanning, ping sweeps, operation system detection, and firewall filter data, as in what rules are those firewalls are going by. And then it also detects services via ports, so it can detect what service is running on what ports. Versions. Not only does Nmap come in two different versions, it also has a suite that can be downloaded. The two versions of Nmap are the classic command line interface, as well as the Nmap suite. The Nmap suite comes with the GUI interface, Nmap, the debugging tool NCAT, the scan comparison tool NDiff, and the pinging tool NPing. Both versions are relatively easy to use. However, the Nmap suite is the easiest to use and comes with a couple other helpful tools. And as you can see here, up here is the classic command line interface. And down here is Nmap. So Nmap is easier to read, like the output, has different tools, labels, and it also has its own command line. So it's everything built into one. Nmap switches. Switches are the different operators you put into the command line when you're running a scan or ping to determine what type of scan you want to run or ping you want to run, as well as what kind of output you want once Nmap is done doing its thing. And you can also determine the speed once it starts. As you can see here is this table is from the official book. It's got right over here are all the different scans and each little switch, the pings, the outputs, and the speeds. The types of scans. When using Nmap, you might need to use a variety of scan types to get different information or to get information at all. Some firewalls might block certain packet types, causing the device to remain hidden during the scan. Some of the scans that Nmap has to offer include SYN, FIN, and ACT scans. So SYN is the default scan, and it's also the stealthiest scan type. according to Nmap themselves. Fin sends a packet with only the fin flag available or enabled. AC is used to determine firewall rules. And Xmas uh, looks like a Christmas tree in the packet, and it sends a packet with fin, PSH, and URG flags enabled. Different scan speeds. In order to help prevent users from being detected, Nmap allows users to change the speed at which Nmap performs a scan. The slower the speed, the longer the scan will take. On its slowest setting, T0, Nmap will only send one packet at a time with a hefty space in between each packet to prevent detection. Or users can pick up the pace at T4 if they are not worried about detection at all. There's a table up here showing you each one. But T0 is the slowest scan possible. It's also the safest one. T1 is a little bit faster than T0. The T2 is the default scan speed. T3 is the default scan speed, however, it scans multiple addresses at once. And T4 is it's faster than normal, and it's more detectable. And it scans multiple addresses at once. Topology. So in the GUI version of Nmap, which is Zenmap, the topology page shows an interactive image of the connections between the individual hosts on the scan network. This page is best paired with traceroute, as you can get a better understanding of the path taken between yourself and the target. It's also like its own mapping tool for a network. And this picture is from one of the earlier assignments. Works cited are, of course, the Nmap page itself, as well as CEH, Certified Ethical Hacker, by Matt Walker. That's where several of the tables, as well as some information, are from. Alrighty. This is Zenmap, or the GUI interface of Nmap. This is offered in the Nmap suite. So this is the main page, and up here on this line is where you would type either the host name of the target or the address of the target. Over here for profile, different types of scans that you can run. So intent scan, where it'll give you as much information as it can find. A quick scan for as little information. This button over here is what will run the scan if you choose to. Let's do rebound security.info, what we had in our quiz earlier today. And let's do an intent scan. As you can see, this is where the output is, and it's already a lot easier to read than if you were in a command line. And it's done. So here is the trace route. So all the steps I had to take to get to the address that we wanted, which was netboundsecurity.info. And down here, it'll show packets sent, how many were received, how long the scan took. Up here, there's all the information. All the different IP ports. IP addresses, all the ports that were open. So it's nice for that. All in all, it's a lot easier to read than command line. And so you can see services over here. Shows you all the different ports and stuff that found. So this one found 2 ports, 80 and 53, and 53 or for the TCP protocol was closed. 80 for the TCP protocol was open. Up here in tools, there's like the rest of the suite stuff that comes with it. And differ, not sure about this one. This is some of the stuff we already have. Different profiles you can make, or just help in general. Up here is where we can do all of our edits. Let me pull up the chart. So when running the scan, so that ran the fastest scan possible, the intent scan. So we can change stuff here if you wanted. So we could do just a quick scan, and it'll already do the modifications for us. Or a slow comprehensive scan will change all the modifications there. So this is where this is the output. This is ports in the host. So this is the host name, the IP address, the port. Topology is the graphical interface. It's interactive as well, so you can do host to viewer, view of the host, all the ports and stuff, trace route. Fisheye, so you can mess with that. Look at all the different connections. This is control, so you can control the whole graphical interface. But this graphical interface is useful because, go ahead and zoom in here with the laptop mouse pad. This is its own personal mapping. It shows you localhost, and it shows from my laptop going through all the different stops to get to our desired target, or reboundsecurity.info. So it's really useful when you're wanting to map out networks. Or you can also, like I said in the presentation earlier, you can put it with traceroute. These are the host details, so it's a lot easier output to read. So ports filtered 998. There's only one open port and one closed port. Here's the IP4 address, the name of the host, name of the site used, the operating system, the accuracy of everything, ports used, OS classes, comments. You make your own little comments. And scans. Oh, well, that's okay. Well, it crashed. So Well, that was in the video anyway, so thank you so much for watching.